Unit operation classroom, uh, which is part of unitoperation.com. Here we are discussing GATE 2024 question 58. A metallic spherical particle of density, this is a particle density and diameter 1 mm, so its diameter is 1 mm, is settling steadily due to gravity in a stagnant gas. So it's settling due to gravity in a stagnant gas here. This is 1 mm particle, and this is the gas viscosity, and this is the gas density. Assume that the settling occurs in a regime where the drag coefficient CD is independent of the Reynolds number and is equal to 0.44. So CD value 0.44, that is in the Newton's regime. All the details are given in any standard textbook like McCabe Smith or Gene Complex, wherever, and the details are, of course, given here. The terminal settle velocity has to be calculated. This is a very standard equation here, and here, of course, G value is given. dP is 1 mm converted to meter, and rho p is value is given. Rho f value, that the fluid density is given. So we can easily calculate the terminal settling velocity. It's a very easy one-step calculation here. Now, just want to add few notes on this particular problem. What is the idea of terminal velocity? It tells you whether a particle in a gas stream will remain suspended or will separate. Let's say in cyclones, fluids, beta spray dryers, electrostatic precipitators, etc. So this is for in the air pollution control. That's for air pollution control. Uh, let's quickly see the derivation of this equation. This derivation is available in any textbook, any standard textbook, McCabe Smith, Gene Complex, again, Bird, Stewart, Lightfoot. I'm just for the sake of clarity discussing this one. Let's say this is a particle here, that was this 1 mm particle. And here downwards, of course, the gravity is working downwards, and of course, the bounce should be working upwards. So the net force downward would be equal to gravity mass. So this is basically the weight of this particle multiplied the mass of the particle multiplied by g. That's the weight of the particle, and this is the weight or the mass of the fluid that's displaced by this particle. So that's a buoyancy factor. So yeah, that's, and then the drag force at terminal velocity is given by this particular equation you see in the standard textbook. So if these two are equated here at terminal velocity, of course, this the net force downwards would be equal to the net force upwards. And this drag force, of course, is working upwards because this is going down. And if CD is 0.44, then we get this equation, which we have used right here in this calculation here. Again, this is nothing new. What is shown here, this is available in any textbook. Just again, very quickly, I want to show the application of this terminal velocity in chemical engineering application. Cyclone separators are extremely common in any kind of process industry and other industries also, and they are used mainly for pollution control, capture of rather coarse particles. So here, this is the cyclone separator. There is a tangential entry of the dust-laden gas, and it just goes down, and the particles hit the wall, and then it's collected in a hopper here. Okay. So in cyclones, typical gas velocity is in the range of 12 to 18 meter per second. That's a typical design value. If the terminal velocity of the particle is less than the gas velocity, then the particle will be carried away with the gas spiral and exit from the top. That will be a poor separation. And therefore, the terminal velocity has to be greater than the gas velocity. Then the particle will hit the wall, and of course, will just come down, and will be collected in the hopper. So this, in this particular problem, let's see if we have to want to collect with this 1 mm particle in a cyclone separator. We have seen the terminal velocities around 15, say close to 15 meter per second. So for the recommended gas velocity should be 12 meter per second. If I put the terminal velocity higher than gas velocity higher than this one, let's say 18 meter per second, then these particles will not be captured and they'll be carried away. So this is a terminal velocity is a very important concept in terms of particle capturing in cyclone separators. So this is my answer.